So as we kind of wrap up talking about weather patterns, I want to revisit this, what we call cyclone, general pattern we call cyclone, mid-latitude cyclone, right? But just in general, what a cyclone is we have a central low pressure at the Earth's surface. An anticyclone is we have a central high pressure at the Earth's surface. And we talked in an earlier chapter recently that actually what's happening at the Earth's surface, a cyclone or an anticyclone, actually needs to be supported in the upper part of the troposphere. And we're going to kind of revisit that. Specifically, one of the ways it can be supported, kind of the convergence aloft that needs to support a high, or the divergence aloft that needs to support a central low at the Earth's surface, is this meridional or wavy flow. This sort of flow, of course, looks like meridional flow to you. That might be our jet stream, kind of showing the general pattern of the geostrophic winds. And of course, it goes from west to east. That would generally support kind of these alternating, actually, cyclones and anticyclones. And I'll kind of show you how that works. Okay. So we talked earlier that if we have a central high pressure down here, where's my little marker? A central high pressure right there, okay? In order for that to be sustained, we need to have air descending from aloft. And in order for air to descend, then at upper elevations in the troposphere, we need to have some sort of convergence. This is, again, kind of something that we talked about before. Now, can you kind of see this meridional or wavy flow up here? Okay, kind of marked out by that ribbon of fast-moving air we call the jet stream. Well, can you see where actually that this is a ridge, okay? And this actually anticyclone is what we say downstream from the ridge. If this is the ridge, it's kind of downstream. So generally speaking, kind of underneath this part right here is we're going to see our high pressure. Let's look at cyclone. Cyclone, of course, cyclonic flow in the northern hemisphere would be counterclockwise, like you see here. It's indicated by a central low pressure. And in order for that central low pressure not to turn into a high pressure, in order for it to be sustained, we need to have air moving upward. In order to have air moving upward, what needs to happen aloft is basically some sort of divergence. So, again, this is something we talked about earlier in this unit, but divergence and convergence aloft actually can be sustained by this waviness, this meridional flow. In general, if there is acceleration, then we're going to have a low pressure created aloft, and that would kind of sustain that would be kind of our diverging air, and that would sustain a central high. And if it's slowing down, then decelerating, that would be a high pressure aloft. And let's see, oh, did I say that wrong? Accelerating would create a high aloft, accelerating would create a low aloft, which would sustain a low below. Is that what I want to say? Yeah, a place for that air to go. And decelerating would sustain a high below. Okay. So I'm not going to get into the nitty-gritty necessarily of it, because there are actually numbers to talk about the vorticity associated with the waviness as those geostrophic winds kind of meander in the upper part of the troposphere. Okay. But just in general, we would associate our surface lows, our cyclones, with an upper level trough, and our surface highs, our anticyclones, with an upper level ridge. So you can kind of see, and they will alternate. So I'm just going to kind of leave you with this slide then. And just to kind of put out, and recently I've gone to this site, so I'm not going to go again, but in order to understand the degree of waviness, or like what the Rossby waves are doing in the upper part of the troposphere, you can check out where the jet stream is. Remember that there is an alternative to waviness, and that is zonal flow. So with zonal flow, it's not going to, that in and of itself is not going to sustain anticyclones and cyclones.